Alright guys, this is going to review satellite and radar. These images can help us look at what's happening with the weather right now and helps us forecast the weather as well. So satellites and radar gives us current, like I said, about current weather information. We have weather satellites. They're the GOES weather satellites. The GOES stands for Geostationary Operational Environmental Satellite. Picture on the right is a picture of one of the GOES weather satellites. Geostationary means that these satellites are orbiting the Earth at the same speed the Earth rotates. So it's placed above a fixed point above the Earth's surface and stays there as the Earth rotates. There are two GOES weather satellites that we use. There's GOES East and GOES West. GOES East is centered over the Atlantic Ocean. GOES West is over the Pacific Ocean. And when you put these two images together, we get nice satellite images of North America. Two types of satellite images. There's visible satellite images. Scans the visible part of the electromagnetic spectrum. Any visible light that's reflecting off of the clouds, the satellite can pick up. These are high-resolution images, therefore they are very detailed. Infrared satellite images scan the infrared part of the spectrum. It detects the heat coming from the Earth. Mainly, in this case, we're worried about the heat that is coming off of the clouds. If you look at this image, these two images were taken at the same time, September 10th, 2008, early in the morning. The top left is your visible satellite image. You can see shadows of clouds. Specifically, I can try and point it out to you. Specifically, this area here, there's like a black line, like right there. That is like shadows of clouds. That you can see. There's some shadows here as well. Those are some taller clouds that are fairly tall, that are tall enough so the sun will cast a shadow. And there are some lower level clouds. Here, this is probably fog. It's easier to see fog when these satellite images are looping. And then there's probably some lower level clouds here as well. I just made a little happy face. That's pretty cool. The bottom right is your infrared satellite image. The colder the cloud tops in this image, the cold cloud tops are indicated by the greens and yellows here and here. And if you compare the two, notice we have these clouds here and here. Well, they're here and here. Okay, and then our lower clouds over here, that's fog, is actually located here. And notice on the infrared satellite image, you can't really see fog. That's because fog is simply a cloud at the ground, and most likely the temperature of those clouds is very near the temperature of the ground. So the infrared satellite cannot see that. Cannot see the clouds itself. It's going to read it as part of the ground. Radar is a tool used by local TV stations and the National Weather Service here in Raleigh. And all National Weather Service offices have their own radar. The radar that they use, they are starting to update these, but it's called WSR, and stands for Weather Service Radar 88D. And 88 stands for 1988. That is the latest technology available for these weather radars, but they are starting to update these. The location of the National Weather Service office in Raleigh's radar is off of US 70 near the Clayton, over near Clayton along the Johnston County, Wake County border. If you're driving eastbound on 70 towards Clayton, you can see a big dome, gray dome, off to the left on the north side of the road, and that is the National Weather Service's radar. Since the Earth is round and the radar beams are sent out in a straight line, the further away from the radar dish that you get, the higher the beam is above the Earth's surface. So that's why, in this case, this example, the radar beam is at an angle like that, because it is always going up. It's always angled at some, tilted at some angle. The bad part about that is that if you're at the outer edges of the radar limits, the images can be distorted. You're not going to see as much detail. This is also true for lake effect snow. Many times, lake effect snow bands are very, very near the ground, and the radar is actually not able to see it. That can become problematic. The numbers and equations here, you do not need to know those. On just the images and the vector, we don't need to know that either. This image, I just want to point out that the dish, the radar dish, is sending out a signal at an angle, and because the Earth is curved, the further away you get from the radar dish, the higher in the atmosphere you are. During severe storms, specifically tornado events, there is a specific type of image that a meteorologist wants to look for if they're going to be looking for a tornado. It's called a hook echo. This hook echo indicates rotation in a thunderstorm. Because of the winds, because they're flowing counterclockwise around that tornado, kind of in that direction. The tornado in this case is actually, this is an actual tornado radar image. The tornado is actually right there. This is the site of the radar. Where you see the circle, the black circle there, that is called the cone of silence. Since the radar cannot be pointed straight up, the area directly above the radar site, you will not be able to see any kind of precipitation. But notice on this radar image, this hook echo, I can tell you the tornado is probably moving in that direction. If you want to be safe, you want to be kind of to the south of the tornado track. All this, the shield of rain and probably some hail in that area, that is obviously rain showers. It could also be debris from the tornado. I know in the Raleigh-Sanford tornado back in 2011, it came right up 401 through downtown Raleigh and up towards Wake Forest. Areas in around the Leesville Road area, Cary, Apex, Morrisville. I know people that had papers, insulation, building materials in their yards because they were in this part of the storm. So it can be very, very dangerous. If you see this on your radar heading towards you, you will need to get to safety. The other thing I want to show is what's called a radial velocity. If in your project you are doing a tornado, you will probably run into this image in one form or another. In this case, the tornado is actually oops. Oh, that's not what I wanted to do. Go back. The tornado is actually right about here. So the image on the left is a radar image. The image on the right is a velocity, and we know velocity indicates you can measure speed and direction. In this case, any of the red here is precipitation moving away from the radar. The green is moving towards. So if you see those two side by side, that means you have rotation. Red moving away from you, green moving towards, and that will indicate some rotation, kind of like that. So the tornado is actually right here, and it corresponds to that right there. This was a quick introduction to satellite and radar. If you have any questions, please come to Smart Lunch.